All right, so we're looking at part F. Suppose you wanted to estimate the proportion of 2 to 4-year-olds who prefer fruit to candy with 99% confidence to within plus or minus 2%. How large a sample do you need? So this problem is actually looking for you to bound your margin of error. You want to make sure that it's no larger than 0.02, right? So we're going to assume that the parameter is close to our sample proportion of 0.1814. And we're going to use that and the equation for margin of error to try to calculate this value of n, right, the sample size. So we set up our inequality. We've got our z star, right, our critical value of 2.576. This is our standard error for proportion. And of course, instead of 1,000 like we had earlier, we have n here because we don't know how big a sample size we need. And then we're trying to get a margin of error that's less than or equal to 0.02. So the rest of the stuff that's going on here is really just the algebra of solving this equation. So we're dividing both sides by this coefficient, squaring both sides, right, to get rid of this big radical. And then the last step here where I'm interchanging this term and n. Really, you can't do that with inequalities unless, of course, you know that everything is positive, right? Because this symbol can change if you were to multiply or divide by a negative, right? So the direction of this inequality could be different if n took on some kind of negative value. So algebraically, this step really isn't sound, except that we know that n is positive, right? We're talking about a sample size. So we're allowed to do something here that may not always be true for an equation that looks like this. So when we do this, we solve, we get that n must be greater than or equal to 2511.7, which means that we need a sample of at least 2,512. Part G. So this time we're saying if we wanted to have a margin of error, again, within 2 percentage points, but this time with 95% confidence, would our sample have to be larger, smaller, or the same size? So what's happening is before we were looking at 99%. Now we're looking at 95% confidence. So, we should know enough at this point about confidence and confidence intervals to know that if you have decreased confidence, you can actually you shrink your interval down, right? But what we're looking at in this question is, what does that say about the size of sample needed to still stay within that 2%? So since 95 is a decreased confidence, we're going to have a smaller critical value. So this guy right here, this 2.576, is actually going to end up being 1.96. I don't have that written down here, but you know what? Let's just say that the z star would be 1.96. And if every single time this value, this 2.576, if that becomes a smaller number, right, then this entire fraction, 0.02 over, of course, it's going to be 1.96 now, ends up being a bigger number, right? So if this whole denominator is bigger and this top stays the same, that would actually decrease the value of n, right? So what happens is, because we're going to have a smaller critical value of 1.96, we'll end up needing a smaller sample size than we did in part F.